All right, it's a rainy day in Fresno, so I put on a rainy day background. We had some absolutely beautiful weather though last 2 days. Can't really complain too much. We probably do need this rain. So got a suited and booted from the mug. Half dark chocolate, half white chocolate. Nice and hot on a cold rainy morning. So let's talk a little bit more about media bias. I was actually listening to NPR this morning, and for quite a while on 1A, they were talking about media literacy, which is really up my alley of what NPR. Let's see, 1A media literacy. Let's see if we can find the program. Yeah, News Literacy Project. Yeah, so we'll probably do something with this. Yeah, news literacy is kind of what I'm getting at with these things. Like every, news story, people have their beliefs and they tend to report stories in line with their beliefs, and it's hard for them to run narratives contrary to their beliefs, which is a form of bias, right? And if we look at, let's see, these people, let's see if we can figure out what bias they have. SCP. Don't use abbreviations like that. Come on. Senior Vice President of Communications discusses the importance of teaching news literacy skills to students. Okay. Let's see here. The SIFT. Russian disinformation in Ukraine. The myth of digital natives' immunity to misinformation. Yeah, I don't know how there is a myth. I mean, the whole thing about, social media spreading news is that people tend to share news stories without digging into the primary sources, right? It's something that I harp on a lot. Like if you want to know if a story is real or not, somebody shares something explosive on Facebook. The first thing I like to do is look at the source for it. Where does it come from? Does it come from a credible source? Is it unsourced? If it's unsourced, it's whatever. But I think it's a myth that people think that digital natives are immune to misinformation. I think the myth is a myth. Because I think everybody knows it's a problem that people just share, the headline matches my beliefs, reshare, retweet, whatever. Confirmation bias at its finest. I think most people understand this is a problem. Who knows? Okay. Discerning fact from fiction on Fox 5 DC. Okay, that sounds interesting. Students empowered to push back against social media algorithms. I don't know. That means using the news to develop students' critical thinking. Always a good thing. Sylvian misinformation in Ukraine and Russia. Put women who capture history with the camera in the big picture. More Russian misinformation. More Russian misinformation. Okay, so let's see what we got here. SVP of Education discussed how to separate online fact from fiction. All right, let's take a look here. Let's see if we can figure out what their bias is.
Great invasion. There are lots of images floating online, and the impacts on gas prices.
Maybe I'm going to get a copyright strike on this.
So how do you separate online fact from fiction with what you posted? Joining us now is News Literacy Project Senior Vice President of Education, Peter Adams, to help us out here a little this morning. Good morning to you, Peter. Good to see you.
Good morning, Jack. Good to see you.
Yeah, I probably can't play this. Oh, the copyright strike thing is ridiculous. It's a lot easier if there's a text thing. Anyhow, yeah, it could be fun to dig into. So here we have the Fresno Bee. Fresno Bee has been running a story over the last couple days over the... Has anyone been following this, by the way? Speaking of news stories that, people don't pay attention to. Has anyone been following the drama going on in Fresno right now, the city council? What if it's from WikiLeaks? That's a good question. So WikiLeaks is a place where you can upload leaked information, right? And the WikiLeaks people, I believe, actually vet the sources. Analysis and publication of large data sets of censored data. So far, WikiLeaks is a perfect documentation record. Yeah. So as far as I know, they've been pretty good at what they've published, which is one of the reasons why Julian Assange is behind bars, in my opinion. But that's just my own personal opinion. Okay. No, not really. No idea what's going on. Okay, so from what I can tell, let me see if I can express this without bias, which is hard, right? And even drawing attention to things is a form of bias, right? Like bias is sort of inescapable, but I think that when you're in news or when you're a professor, I think it's your ethical responsibility to try to minimize the bias as much as possible. And so I'll try to present this as neutrally as possible. So there's kind of two different camps in Fresno government right now. You have 4 Democrats, and you have Gary Bredfield, who is a Republican. And they're sort of... And Bredfield and Lisa Smitkamp, the city's DA, or DA, city attorney? What's her? District attorney, yeah, she's a DA. Are accusing the Democrats of misusing their city credit cards, misspending money. And the Democrats are accusing Lisa Smitkamp of using a personal relationship with a FBI agent to get information. Like there's a lot of drama flying around right now, and I think it's fairly neutral to say there's a lot of drama flying around too, because you don't accuse people of sleeping around without it being drama, in my opinion. So yeah, so you can read the story. I'll post it on here. You can read that, and they're going back and forth on these things. So yeah, so the NPR story was pretty good, and I might even assign it as a required reading or required listening if I can find a copy of it. So a lot of the things they're saying are the same things that I talk about, which is that anytime you see a news source, you have to kind of ask yourself, is it credible? What's their source? What's their bias? That kind of stuff. If you're seeing something coming from Fox, it probably has a right-wing bias. If you see something coming from CNN or MSNBC, it probably has a left-wing bias. It's just, it's not controversial for me to say that, even though some people might say that, if you look at Harvard. Yeah, so this would be Trump's first year, I think. Yeah, first 100 days. Yeah. So here is how the different media outlets covered Trump, whether the stories were negative or positive. And I believe their methodology, I've looked at this study before, it was focusing on the kinds of adjectives and things like that they used to determine if they were positive or negative coverage. You can see that Fox is well, more positive than the other outlets. CNN and NBC are the worst, and this is Harvard. It's not like it's, Oral Roberts University or something, And so you can see that, depending on, who knows who's right, and that's kind of thing. I don't know which of these is the most accurate, right? How much positive and negative coverage should Trump have had? I don't know. Basically everybody has their own mind. Well, it should have been here, and then everybody who's on one side is biased one way, and everyone who's on the other side is biased the other way. It's just interesting as a comparative thing to kind of see how the different media outlets have their coverage, right? So, like I said, I don't think it's actually really CNN has disputed the fact that they are a left-wing outlet, and they have 93% negative coverage, right? So, but he deserved it, So who knows? Maybe they're accurate, and just everybody else is far too favorable towards Trump. Who knows? So, let's keep going. As far as the discussion forums, I know some people were having trouble finding the people that responded to them, so I'm just not going to grade you on that. So just don't worry about it. If you posted your thing, then you're fine. Don't worry about step 3 on that. Let's see if there's anything else on manufacturing consent we need to talk about. I think we're good. Okay. All right. So, let's keep talking about science. Professor X. You can find it if you go into the gradebook. Yeah, basically, I know a number of people are having trouble, and I don't like being really punitive if there's some sort of like problem with the website. So, steps 1 and 2 I'll grade you on. Step 3, whatever. If you did it, good for you. What week is this? Week 11, is it? Or is it week 12? You don't know? You don't know what week it is? Lost all sense of time. Week 11, yeah. Okay, so next Friday, there will be a midterm. And the midterm, since that butts up against spring break, I guess you'll have all spring break to do it. I'm planning on doing some media criticism kinds of things, or science paper analysis kinds of things. So all these things we've been talking about for the last week or two, pay attention, because it's coming on the midterm. If you remember the very first day of school, where I gave you a website and said, hey, is this true or false? And a lot of you got it wrong because you believed the website. The website was lying to you, despite it coming from a museum website, right? So I love doing that kind of stuff. I love messing with students. It's really the reason why I teach. No, the reason for it is because to be a critical thinker involves not believing everything you hear. That's sort of the essence of being a critical thinker, right? Just because somebody tells you something doesn't mean it's true, right? So, and that includes me. Like I have made mistakes in my lectures in this class. For example, when I was talking about racism, and I said, who is responsible for blocking Japan's racial equality proposal to the League of Nations? I said it was Australia's fault that it was blocked. That was true. But then I said, it wasn't always America's fault. Woodrow Wilson was kind of complicit in that. And I think it was named George or Lloyd or whoever from the UK was also complicit in that. So basically, Australia didn't want there to be racial equality because that would mean they couldn't block Japanese people from coming to Australia. But despite a majority of countries voting yes on the racial equality proposal, it was Woodrow Wilson who said, well, I'm just going to say it's no anyway, and then moved on because he didn't want to piss off Australia. So it was Australia that led the charge, but yeah, Woodrow Wilson kind of has a lot of blame to do with that too, and the UK as well, for that matter. So it is not doubt everything. Yeah, I mean, doubt everything up to a point, and that's the other side of the coin. Is that it's possible to just become so cynical and so skeptical you don't believe true things, and that's bad too, right? Like if you just don't believe true things, then that's just as bad as believing false things, or maybe they're different, but like you want to believe true things and you want to not believe false things, right? Like that's the whole point of critical thinking. So, am I going to post a practice midterm like last time? Sure. I'll probably post all of my former midterms, and yeah, there's going to be a lot of fallacies on it. It's going to be comprehensive, so you can't. I'm not giving you permission to forget what we did in the first trimester, the first third of the semester. Okay. Yeah, I left the window open on my car today and went to the mug with my butt soaking in water. It was hot yesterday, so I left the window cracked, and then it rains a third of an inch, and I get to sit on a puddle. Okay. So, big topic for today is deductive, inductive, and abductive reasoning. So if you guys remember how much fun it was to learn valid, invalid, and sound, we got another trilemma kind of thing coming up here. Okay, so the 3 big topics for today. 3 topics for today. Deductive, inductive, and abductive reasoning. Okay, we'll go through each one of those. But you should be able to look at an argument by the end of today, or by the midterm. You should be able to look at an argument and tell me, is this argument deductive? Is this argument inductive? Or is this argument abductive? Okay. So let's go. So, deductive reasoning. Deductive reasoning is, the easiest way of putting it is, Deductive reasoning is when the conclusion must always follow from the premises if they're true. Actually, even if they're not true, it's a valid argument is deductive reasoning, basically. So, deductive reasoning, all the three line syllogisms that we were doing, Socrates is a man, all men are mortal, therefore Socrates is mortal, that's deductive reasoning. The conclusion must absolutely follow from the premises if the logic is valid, and the conclusion is true if the premises are true. Okay. That's deductive reasoning. We've been covering it. All the stuff we were doing with valid, invalid, and sound, all that stuff was deductive reasoning. Right? Premise 1, premise 2, if the logic works, the conclusion must be true if the premises are true. Okay. Premise, squares are regular 2D polygons with 4 equal sides. Premise, I'm looking at a regular 2D polygon with 4 equal sides. Conclusion, I am looking at a square. It's a valid argument, it's not sound. This is not actually a square, I don't think. Does that look like a square to you, or does that look like a rectangle? Because it kind of looks like a rectangle to me. I don't know. What do you think? Yeah, absolutely. Does that look like a square? Okay. I don't know. More rectangle? Let's find out. Let's do some science. Let's draw shape. And then if you hold down control, no, not control, is it? Shift. There. If you do shift, you get a square. Yeah, it's a rectangle. Okay. So, is this argument valid, invalid, or sound? What do you think? The intent is a square, but it is a rectangle. Yeah. Is this valid, invalid, or sound? This deductive argument here. It's a deductive argument. Okay. Or deductive. It's a deductive style argument. What is it? Does the logic work? Question 1. Does the logic work? Squares are regular 2D polygons with 4 equal sides. Premise 2, I'm looking at a regular 2D polygon with 4 equal sides. Conclusion, I'm looking at a square. Definition, I'm looking at a thing that matches the definition, therefore I'm looking at the thing. It's valid. Yeah. Premise 2 is not true, though. I'm not actually looking at a regular 2D polygon with 4 equal sides. So, okay. This is valid but not sound. Okay. Because this is not actually a square. It's a rectangle. All right. Here's another one. If x then y, if y then z, x is true, therefore z. So transitive inference. That is deductive reasoning. And the reason why this is deductive reasoning is because if the premises are true, then the conclusion must absolutely 100% all of the time be true. Okay. All mammals have hair. All cats are mammals. Toby is a cat. Therefore, Toby has hair. I don't know who Toby is. If Toby is a cat, then this is sound. If Toby is a person, maybe I was thinking, who's the Spider-Man actor? It's spelled with an E. Okay. You spell it? Maguire. Maguire, not Maguire. Look. So what about example 2? Valid, invalid, or sound? What do you think? Number 1, who knows? Because these are just symbols. Like, who knows? We know it's valid. Like, who knows what these things are? What about number 2? Valid, invalid, or sound? It is. If you're saying it's sound, then you're agreeing that Tobey Maguire is a cat. Was he in Cats? That's actually a good question. I see what you guys are getting at, but no, it's not sound. It is not sound because Tobey Maguire is not a cat. So sound means the premises are true. Valid means the logic works. Sound means the the logic works and the premises are true. It is not the case that Tobey Maguire is a cat. He is a spider, not a cat. Thank you. Yeah. It is valid but not sound. Yes. Okay. The logic works. However, the premise 3 here is not true. All right, so we've done deductive reasoning before. It is now time to learn inductive reasoning. So inductive reasoning is the reasoning used in science. Okay. Inductive reasoning is the reasoning used in science, and it is not certain. Deductive reasoning is certain, right? If it is the case that all mammals have hair and cats are mammals, and Tobey Maguire was a cat, 100% guaranteed, certain, Tobey Maguire has hair. Okay, certain. Inductive reasoning, not so much. That's why when we were doing the science paper thing, which I read probably 180 science papers yesterday, grading all those things, which, yay, go me. That's why there's a p-value. The p-value is sort of a way of constraining the uncertainty. It doesn't always work, like we talked about, but the notion of a p-value, and this is something that about a quarter of the class got wrong, or maybe a third of the class got wrong. That like about a third of the class just got the p-value wrong or misunderstood what the p-value is. The p-value is if you give people M&Ms over 2 weeks, you have an experimental group, you give them M&Ms, you have a control group, you don't, and then you weigh them, right? There's always going to be fluctuations in people's weight, right? Some will go up, some will go down just naturally, and so there's random chance. So you give them the experimental group M&Ms, you don't give anything to the control group, you weigh the two groups afterwards. The experimental group weighs a pound more now than they did in the past. The control group's the same, whatever. The effect size is 1 pound. They gained 1 pound. But we don't know if that change is significant or not. It could just be random chance. And so the p-value, these statistical tests, are a way of us trying to get certainty in an uncertain world. And so if we do a p-test and we determine that the p-value is less than 0.05, which is the standard cutoff, then that means that we are 95% certain, sort of, and again, people who are stats people, you can yell at me, it's fine, I'll accept the abuse. But it means basically we're 95% certain that giving the people M&Ms caused them to gain weight. A lot of people confused effect size and the p-value. The p-value is the certainty, or specifically, it's the percent chance the results were due to chance. So if you have a p-value of less than 0.05, that means there is a 5% chance or less that the results were just due to random fluctuations. Okay? That's what the p-value is. If you give me a scientific paper that doesn't have a p-value on it, I will throw like for something like that where you're doing an experiment, right? And you don't have a p-value on it, I will throw the paper away because it's like, okay, you gained a pound, but it could have been random chance. How do you know if it was random chance or not? If you didn't do the stats, this thing is worthless. Okay, and so there will be a science paper analysis on the midterm as well. So if you have any questions about p-values, please ask me, because like about a quarter or a third of the class doesn't get it. All right, so with inductive reasoning, that's the whole thing, though, is that you don't have that certainty. It could have been due to chance. Like, you might have given people M&Ms, and you weigh them, and they're 2 pounds heavier now, but it could have just been a random fluctuation. You don't know for certain that the M&Ms made them fat. Okay. So, inductive reasoning is the notion that you can make predictions for the future based on the past. That's the core thing of inductive reasoning. Is that based on the past, we can make predictions of the future. The whole point of doing an experiment to see if feeding M&Ms to people to see if they get fat is like, well, what if in the future you want people to get fat? Like there's cancer patients. Like the friend of mine that was died from cancer back in February, he had pancreatic cancer, and so he was losing weight, pretty dramatically. And my own grandfather, when he got cancer, he lost a lot of weight. And probably would have died, except we found a food that he loved, that he could eat and tolerate, that was very high calorie, which is the exact opposite of normal, right? Normally you want to avoid junk food, but it was cheese puffs. It was like, if you remember Cartman cheese cheesy poofs in South Park, like that was literally what saved my grandfather's life. Was that he was able to eat large amounts of them, and he got the calories that he needed to maintain his body weight, right? And so it's possible you do a science experiment, you find that if you give people M&Ms, they put on weight. Cool. Now in the future, if you have somebody who has cancer and they can't tolerate a lot of food, but M&Ms are still good, you're like, oh, cool. Science has shown in the past that eating M&Ms makes you fat. So here you go. Enjoy, right? Cancer kind of flips a lot of the nutritional guidelines on their head, you know what I mean? So all of a sudden, so it's kind of like an experiment. Yeah, inductive reasoning is the reasoning of science, basically. Based on the past, we make predictions from the future. Okay. My friend has always picked me up from the airport before. Therefore, I have confidence that he will pick me up on time tomorrow. That's inductive reasoning. It doesn't have to be science. It doesn't have to be an experiment. Anytime you're using the past to reason about the future, that's inductive reasoning. Okay? And anytime you have a science experiment, that's going to be inductive reasoning. Write that down. If I do an experiment where I go out and I put down glyphosate, Roundup, right? Is anyone here in ag? Do you know what glyphosate is? Roundup. So it's a weed killer, right? So let's say I do an experiment. I go out there and I spray Roundup on my bushes, and then I measure how many bees we have, and maybe it causes a decrease in bees, right? And then you conclude from that glyphosate kills bees, right? That's inductive reasoning. And the point of that is that if I were to go out and spray glyphosate next week, it would kill bees again, right? That's the whole point of inductive reasoning, is you look at the past, you draw a general conclusion from it to reason about the future. The main ingredient around it, yeah. Is inductive reasoning similar to inferring something? Yeah. You look at all this data, and you're like, all right, the data suggests that glyphosate kills bees. Okay. But you could be wrong. You could be wrong. You know, maybe it was just a coincidence. Maybe the queen bee just decided, nah, this place sucks, and just left. And so when you go out to measure the bees, they just left. You know, you never know for certain. You know what I mean? And so that's the trouble with inductive reasoning, is that you never really know for certain. And there's always a chance you're wrong. There's always a chance somebody will repeat the experiment and discover you made a mistake. It's fine. It's all part of science. The bigger problem is this. The bigger problem is called the problem of induction. And this is one of the sort of weaknesses at the heart of science. Okay? And the problem is there's no particular reason why the future should be like the past. Right? Even the laws of physics. We're pretty certain that, electrons today are going to have the same mass as an electron tomorrow. But how are we certain about that? We can't be certain. This is sort of we just kind of have to believe that, because there's kind of nothing else we can do. If you want science to take place, you have to just kind of assume that tomorrow is going to be like today, and that's sort of unjustifiable, And so Bertrand Russell came up with this argument here. So he said, imagine you're a turkey on a turkey farm. And it's like Ken Ham's argument about why we don't know the age of the year. Yeah, but it's also an anti-scientific argument, Ken Ham's thing, because science is fundamentally predicated on that the rules of physics don't just change from minute to minute, right? If you were to pluck your guitar, and you're like, all right, if I pluck this string here, I get this note, and then I pluck it, and then I pluck it tomorrow and it turns into a butterfly. Science is impossible. You know what I mean? If it could just do something completely different tomorrow, science would be impossible. And so one of the sort of baseline assumptions of science is that just the laws of physics are just kind of constant, right? Okay. So Bertrand Russell, turkey argument. He said, imagine you're turkey to turkey. And you love your farmer, right? Every day he comes by, he feeds you corn, he pets you, he takes care of you, you get sick, he gives you medicine. You're like, man, that farmer is a good guy. Man, look at this guy, he's always taking care of us, right? And then one day, around Thanksgiving time, you notice a bunch of the turkeys all going into the shed. None of them were coming out. And, your buddy's like, I don't know, man, I don't know if we should go in there. You're like, but hey, this guy's always been good to us. I trust him. Let's go in, right? And that's the problem of induction, is that just because somebody was good to you in the past doesn't mean they'll be good to you in the future, right? There's no, just because you have an established, past with something doesn't mean it'll always be the same. And there's just no overcoming this for science, right? Like, it's just kind of a weakness at the heart of science, And for things like particle physics, I mean, people are just kind of fine saying, an electron today is going to behave like an electron tomorrow. But at a bigger, higher level, let's say that, you discover a new teaching technique, and you do a teaching technique, and you do the intervention, and the kids do better, And then you're like, well, all right, let's do this teaching technique again next year. But there's no guarantee that it'll still work next year because things change in the world, right? Like, back in my day, they still had slideshows, where they'd actually have slides and they'd click through a slideshow. My biology teacher had all these slides all set up, and you'd click through them. Here's a bush or whatever, And there's no guarantee in the future that kids will respond, not to a PowerPoint slideshow, but an actual slideshow, that they will respond the same way in the future they do in the past, and so there's just no way of saying this is the best teaching technique, because the future is always in flux. Things are always changing. Okay. Here's another problem. Let's say you have a barrel of jelly beans. It's the Bernie Bott's multi-flavored beans, whatever it's called. What's it called? Bernie Bott's every flavor bean. All right. And so they've got flavors such as blueberry, booger, candy, earwax, earthworm, dirt, cinnamon, cherry, lemon, marshmallow, rotten egg, vomit, celery flavored. And so if you have a million jelly beans and you eat them, you're like, oh, it's lemon lime flavored, lemon lime flavored, lemon lime flavored, lemon lime flavor. Then scientifically speaking, you would conclude this is a barrel of lemon lime flavored jelly beans. And as long as you don't eat the booger flavor one, you would be confident that this is just a barrel of lemon lime flavored jelly beans. And you'd be wrong. There would be a booger in there, and you would be very unpleasantly surprised at some point, right? And this is a problem with crop inspection, right? Right? When you get produce from another country, you don't eat all the produce coming in to test it, because then there's no produce left. You have to sample it. So you get a shipment of lettuce, right? You pull out one of the heads of lettuce and you send it to the lab and see if it has E. coli on it. But maybe that one didn't have the E. coli on it, Maybe just one of them did, and a kid dies of E. coli poisoning. You missed it, right? It's a problem. There's no good solution to it. All we can do in most of these situations is we sample. We just sample randomly and test them to see if they have any dangerous chemicals or bacteria or whatever on them. And we miss things all the time. It happens. Okay. Yeah, another one would be, I flipped a coin 3 times and each time it comes up heads. Therefore, it will always come up heads. There's no justification for that. Sometimes things are just coincidence. Contrawise, you have the gambler's fallacy, where you say, I flipped a coin 3 times, it's due. I'm going to bet all my money on it coming up tails. It's due. It's due. It's got to come up tails. The universe balances itself. Wrong. It's still 50-50. It'll come up heads or tails if it's a fair coin. Okay. Yeah, so the big problem with this is that it undermines science, right? Science is fundamentally predicated on inductive reasoning. And inductive reasoning is inherently, problematic, right? People believe the sun will rise tomorrow. Some people believe the sun will always rise tomorrow. That's wrong. At some point, the sun is going to devour the Earth, right? And the sun won't rise anymore because the Earth is gone, right? It's guaranteed to be wrong, but we believe it anyway. We always believe the sun will rise tomorrow. So, you know, it's a problem. It's one of the sticky bits when it comes to science. But we treat it as if it was true anyway. Yeah, I'll meet you at dawn tomorrow. Hope you won't be around for that. Yeah. But I mean, who knows? Like, you know, I mean, even though we think the sun is going to devour the Earth in a billion years or whatever, you know, what if an alien comes by and just blows up the sun? Oops, sun won't rise tomorrow. You have absolutely no way of knowing that the sun will rise tomorrow. It's risen in the past, and based on that, we can make a prediction that it'll rise tomorrow at 7:04 in the morning or whatever it is. I don't know what time sun rises. But yeah, an alien could just come by and be like, pew, pew, and blow up the sun. You'd be wrong, you know? You'd be wrong. And so science is kind of, you know, it's just kind of like, yeah, I mean, assuming nothing like that happens, then it'll rise tomorrow. But that's an assumption. So, you know, so why do we trust science, right? Because it's been proven to work. But that's also inductive reasoning. You know, in the past, science has worked. Therefore, I will trust science in the future. Is also inductive reasoning, right? Treat every day like your last kind of belief. Yeah. Right? And if you look at, you know, if you look at like what people believed 100 years ago in science, like almost all of it's wrong. Right? You know, look at like maybe go back even a little bit further, because like 100 years ago, I think we're getting into like Einstein, right? When was his miracle year? 1905. Yeah. So let's go back. Let's go back to like 1890. Right? And think about like what people believed in science in 1890. How much of that is still believed today? Anyone know some of the things that people believed in the 1890s in science? Any examples? Phlogiston. The luminiferous ether. Space travels. Earth is flat. No, they knew the Earth was round 120 years ago. Yeah. In fact, the ancient Greeks knew the Earth was round. Like the notion that everybody thought the Earth was flat is sort of a urban legend. Yeah, the luminiferous ether was supposedly the medium that light traveled through, and it was not disproven. Okay, Michelson Morley was 1887. Okay. So, yeah, they believed in that. Then it was disproven. Phlogiston disproven. Scientific racism was a big thing, right? That was we talked about that, right? And then that led to some problems, right? You know, like World War II, right? Japanese attitudes towards a lot of the other Asian countries was based on scientific racism. You know, it's not like science is a neutral, harmless, you know, way of learning about the world. Like, it has real world consequences, and that's something you will hear me harp on all the time in this class. All the time in this class is that none of these things are consequence free. You have to think about the consequences of your actions. And so science, I actually don't need to put quotes around it. It was science at the time, coming up with the notion that there was better races and superior races and lesser races that deserved to be dominated, led to all sorts of horrible suffering and wars and ethnic cleansings and things like that. It was science, right? So, yeah, they did craniometry? Yeah. They believed that they could determine, you know, which races were superior from like measuring people's skulls. And what was it called? The thing that measures the bumps on the heads. I can't remember the name of it now. Phrenology, that's it. Yeah, so phrenology, yeah. So they could like measure the bumps on people's heads and determine, this one has to do with language and, hope and wonder and all nonsense, but it was science, right? Or some form of science. Okay. So that's the problem, right? And if you look at like the history of nutrition, how many things has the scientific field of nutrition gone wrong over the years and caused countless deaths due to obesity, heart disease, things like that? Like, it's not consequence free. The whole point of science is that it's supposed to be sort of a neutral arbiter of what exists in the world, but it's not, right? It has real life consequences, and scientific mistakes have real life consequences. And there's a conspiracy theory that's maybe not a conspiracy theory, which is why sugar was promoted at the expense of fat. Like, there was a push in the 80s to eliminate fat from foods and put sugar in its place. And there's a conspiracy theory that's maybe not a conspiracy theory. This was done at the behest of scientists working for Big Sugar or something. So I haven't investigated that. I don't know if it's a conspiracy theory or not. So you can look into that on your own. I don't know. Okay. So that's inductive reasoning. Okay. Based on the past, let's make arguments about the future. So pizza's nutritious in the eyes of the U.S. federal government. It is. Pizza's great. I just had pizza last night. Eugenics, yeah. Eugenics is another excellent example, right? Let's, science says we can breed better horses. Eugenics says let's breed better people, right? And if and this is again it's not a consequence-free scientific belief, right? Like, California sterilized people, right? So there's a program to compensate the survivors of state-sponsored sterilization because they're still alive. There's at least 600 people who are forced sterilized in California that are still alive. Under a policy of eugenics. So Hitler, no, this is California, not Hitler. It's California, and California's always been a very progressive state, and eugenics was a progressive cause. This was advocated by like Sanger, the founder of like Planned Parenthood, right? And so there's a conspiracy theory that Sanger wanted to eliminate the black race by encouraging birth control in black people, and I have dug into that one, and I don't think it's exactly accurate. Like, she did promote birth control, but she didn't have, like, I haven't seen anything that was like from her saying I'm trying to eliminate like black people. I think she was just on board of the everyone should have access to birth control train. There's some quotes that kind of make it sound like she was just trying to commit genocide, but I think it's kind of an urban legend that she was like trying to genocide black people. But I haven't fully investigated it, but that's kind of my take on it. I have looked into it. So yeah, if you want to dig into that, dig into the history of Planned Parenthood and Margaret Sanger and stuff like that. So tell me if I'm wrong, because like I spent some time investigating it, but not like I haven't read her diaries and things like that. Okay, so let's get into the last type of reasoning. There's deductive, there's inductive, and then there's abductive. So abductive reasoning is the reasoning Sherlock Holmes uses. Sherlock Holmes calls his reasoning deductive reasoning, and it's not. It drives me crazy. He does not use deductive reasoning when he solves cases. He uses abductive reasoning. There's a scene. I don't know if you've seen the Science of Deduction. Oh my gosh, it kills me. There's a scene in the BBC Sherlock game of deductions. He plays a game of deductions with his brother, and they like have a hat, and they like throw the hat back and forth, and his brother Mycroft he throws a hat to his brother, and the brother deduces something about the hat and throws it back to Sherlock, and Sherlock says, well, clearly the person's an alcoholic, and he throws it back to Mycroft, and this is a tea drinker, and they throw it back and forth. That's not deductive reasoning. That's abductive reasoning. So abductive reasoning is a best guess. Okay? So abductive reasoning is when you look at the body of evidence and you make a best guess as to what is true. It's the kind of reasoning you use in a crime scene. So if you are a detective at a crime scene and you've got all this evidence, there's a scream, you hear so a neighbor reports an argument, there's a bang, police are called, you walk in, there's a person dead on the floor, shot. There's a bullet hole, dead. Okay? So you have to figure out what happened, right? And they'd probably the first guess would be like, that person shot that person. Not necessarily the case. Like, they could have shot themselves, it could have been a struggle, self-defense, who knows, right? But their first guess is going to be like, that person probably murdered that person, so they're probably going to arrest them, right? Just so they don't run away, right? But the thing is, like, that's not enough to convict somebody of murder, right? You can't just be like, best guess, it's murder, and convict somebody. You have to gather evidence, right? And so, like, they'll probably arrest the person, put them in jail, just so they can, so they don't run, right? And then they'll probably, fingerprint the gun, interview any witnesses that are nearby, photograph the crime scene, look for signs of a struggle, and maybe it misfired, who knows, right? Look for bullet holes in the walls, things like that. And so they're going to gather all the evidence they can, and then if it goes to trial, what happens is the district attorney, the prosecutor, will say, here is the evidence, right? We don't have any direct evidence the person A shot person B. However, we did hear the neighbor say, I'm going to kill you. Heard screaming, heard a gunshot. There you go. There's fingerprints from person A on the gun. There is no sign that person B was trying to kill person A. They're dead. And then the jury has to vote on the evidence, like, is that sufficient evidence to convict somebody of murder, right? And the defense will then present their evidence, like, no, this person was trying to kill me, the neighbor couldn't hear them say, I'm going to kill you, and so basically what happens is the prosecution presents their evidence, and the defense cross-examines. The defense presents their evidence, cross-examination, maybe a redirect, whatever. And they present all their evidence, and they hand it to a jury, and then the jury uses abductive reasoning. All right, we got evidence for, got evidence against, and there's a standard of evidence. And so in order to convict somebody of a crime, you have to be convinced beyond a reasonable doubt that they're guilty, which is, 70, 80% convinced, right? In a civil case, it's a preponderance of evidence. If you're 51% convinced the plaintiff is right, you rule, the plaintiff wins. 49% they lose. So that's abductive reasoning. You got evidence for, got evidence against, you weigh them, and then you make your determination based on the evidence. Okay? It's a best guess. You could be wrong. You could be wrong. Happens all the time. New DNA evidence turns up, and yep, sorry, we got the wrong person. Let him go. My bad. So here's the summary. So if you have a deductive reasoning argument, you can be absolutely certain. If the argument is sound, you can be absolutely certain the conclusion is true. Okay. If you have a valid argument, then you're conditionally certain. In other words, in a situation like this, if X, like if these two things are true, then you can be absolutely certain that Z is true, right? It's conditional. Sometimes, because these are just variables, like some of the time, right? So if you have a valid argument, then it's worth something, right? Because the conclusion is true if the premises are true. You kind of plug in new premises and you get a true conclusion. So deduction is certain. Okay. Inductive reasoning is probable. and I'm going to put up a quiz today that's going to have different types of arguments. You're going to have to identify them. Is this deductive reasoning? Is this inductive reasoning? Is this abductive reasoning? Okay. Abductive reasoning and inductive reasoning are not certain. They're probable. But the difference between inductive and abductive is that inductive is based on the past to reason about the future. Whereas abductive reasoning is like, you got this evidence here, you're going to weigh it for or against. Okay? That makes sense? Do you think you can identify it if I come up with some sample arguments on the quiz? Do you think you could pick out which of the three an argument is? All right, let's find out. Let's find out. And these will be on the midterm too. So, in general, if you see something that's a scientific paper, it's probably inductive reasoning. We shall see. We shall see. All right. The midterm is going to be next Friday, and you'll have all spring break to take it. So it'll be same format as before, just more topics. It will be inclusive from the previous midterm. So there will be all the stuff on the first midterm, plus all the fallacies, social issues in computer science, types of reasoning, probably some Scratch stuff on there as well. I think I'll come up with another Scratch assignment for you, maybe tomorrow or Wednesday. All right, any questions? All right. Ooh, actually, you do have a question. All right. All right. Regarding the assignment. Which assignment? The next Scratch assignment or the last one? Okay, go for it. You forgot you were signed into the wrong account. Yeah, there were 4 or 5 students who didn't share the project properly. So I told the TA to just give them a 0. And I figured that would motivate students to contact me and figure it out. So if you got a 0 on the Scratch assignment but you did it, just message me. I'm not here to be punitive and like, you know, tank your grade or whatever. But, you know, a 0 is a great motivating factor for people to contact me and be like, but I did it. Just contact me. It's fine. I'll give you the points. It's not a big deal. Yeah. You made a boss. Cool. Yeah, Sam. Yeah, just message me, and then I'll. Yeah. In fact, if you're online right now, just message me right now, and I'll take a look at it. And I'll fix your points. So yeah, the TA's like, I feel bad giving him a 0. I'm like, no. They're gonna notice, and they're gonna contact me like, why did I get a 0? And then we'll fix it. All right. Yeah, because I mean, the assignment said, click on this and share this, and So a 0 is a fair grade, but at the same time, like, I'm not in the business of like hammering students on their grade. So, alrighty then. All right, I'll see you guys on Wednesday. Peace out.